Hi, I'm Dr. Louis Elliott, Assistant Professor of Mechanical Engineering. Welcome to our Intro to Basic Engineering Science, our physics labs for mechanical engineers. This is room 424. Here's our safety signage. We do have some hazards, electrical hazards because of water and electricity, and some pinch points and possibly trip hazards. And here's our contact information, bin swords. Okay. Our room capacity is 24. And this is our lab. I'd like to point out our safety signs, our exit sign here above our exit door. And of course, our campus-wide fire alarm system. And over here is our fire extinguisher, up to date. And over here is one of our 2 first aid kits. We have a 25-person kit here because the room capacity is 24 plus we make 25. We also have a secondary 10-person kit on the back table there for an extra safety. There is not a yellow sheet or a SDS folder for this lab. There are no dangerous chemicals or materials that would need those. Mainly this is all mechanical equipment. Okay? So this is the lab space. We have 8 stations, and with a max capacity of 24, that is typically 3 people per lab. So they do work in teams. We have modern computers that have our data acquisition system for a variety of experiments that we do, and dual monitors so the kids can work well together. They do their work in here. These labs, the labs work under our college-wide safety system, and before the students are allowed to take part in the lab, they have to take an online video course to pass that has the safety information in it. So before you're allowed any lab in engineering, the students will have had to pass this safety video. The main labs that we do in here, as I said, are mechanical-minded physics labs. So we do straight line motion, we do projectile motion, gravity, air resistance, friction. We do energy, conservation of energy, and work, and that's the bulk of the modern physics. We don't have an eye station or a wash station because we don't have those chemicals or anything dangerous like that in here. We have all of our supplies for all of our labs are in our cabinets and under these desks here. All the stations are outfitted with a Vernier Pro lab data acquisition system. So the different experiments equipment to connect to this, and then the students access and analyze their data on the computers. And you can see also our COVID safety information is on all 4 walls for the university requirements. And I think that's it. Did we cover everything?
Hello, I'm Gary McDonald. I'm one of the 2 instructors for this senior ENME 4470 lab. It's called ME Experimental Laboratory. What you see up here on the wall is the signage there's 2 rooms actually that are adjacent to each other, which is the primary lab. And we have one secondary room that you'll see later in the video that we also house some equipment. And my purpose is to work in basically room 124, which is on the mechanical systems side. You'll see later on in the video, Dr. Charles Margraves and he will be looking at describing you the energy system type labs that we have on the other side of the room, which is room 123, and the additional room, which we call room 108. As you see on the signage, we talk about our electrical hazards we could have in here since we have water. We also have some mechanical and chemical hazards. Our chemical is mainly dealing with propane. We used to deal with gasoline in here because we had an internal combustion engine that was functioning at one time, but now it's mainly just a propane gas. And we also talk a little bit about in our signage about eye and ear protection when it's absolutely needed. We also have other safety, which is our fire extinguisher over here on the wall. We keep our first aid kit here on this table near it, so we know we're always where it is in room 124. And we also have signage above the two doors. There's the entrance door to the hallway where you see an exit sign, and then there's the door out to an open outdoor plaza, which also has an exit sign. This particular lab is, since it's a senior lab, what we try to do in here is to talk a lot about sensors and how sensors are going to be integrated into both mechanical systems, which is my application, and later on into energy systems. What we've done on this side of the room is taken existing equipment that we've had for a long time and instrument them with electronic sensors and interface those sensors through particular types of interfaces to LabVIEW's programming. What you see real quickly in this first experiment is just a simple linear vibration tester. It's a spring, it's a mass, and it's a viscous damper. The original outputs of it were the amplitude and phase drum, but what we replaced it with is an LVDT for displacement measurement, a velometer for velocity measurement, an accelerometer here for acceleration measurement, and we also have another LVDT that measures the displacement of the slider. All of that information is actually being displayed from that sensor information through the interfaces and the DAC board in the computer to what you see there on the LabVIEW screen. We tried to write our own LabVIEW software for each of these particular experiments, and that's the ultimate result that you see there on the computer screen. Okay, let's come around the other side of the room here. And you can see we've had limited number of chairs because this was a COVID limit of 10. Normally we could have up to around 20 people in this room, but we did a COVID limit of 10 back when that was in play. So we reconfigured these chairs whenever the particular experiment is going on. And usually the experiment goes on for 2 weeks as different groups of 4 or 5 rotate in and out of it. This particular experiment is just a simple beam bending experiment. It has 2 sensors on it, an LVDT for displacement showing the displacement of the beam, and then there's strain gauges on the top and bottom surface. The reason we still do that is so we can talk about strain gauges in their purest form. And we do 2 kinds of tests for this beam. A normal static test like you'd have in a mechanics materials lab, but also we try to vibrate the beam and try to determine its natural frequency. We also have it hooked up to a computer with a different LabVIEW application that we wrote for this particular experiments with only a 2 sensor input, the LVDT and the strain gauges. The next experiment actually was meant to be a demonstration, but we turned it into an experiment, and it's basically what is known as a static and dynamic balancing system. You have a shaft with bearing supports, and it's being driven off an electric motor through an O-ring to spin the actual pulley, and you put these discrete weights on here, either with or without centers, and that allows you to be able to statically balance it, looking at just angular orientation, and then static and dynamic balancing using angular orientation and axial location. The only sensor we have on this is a 3-axis accelerometer, and it's given us 3 directional accelerations that we show here on the LabVIEW front panel, which is a very simple virtual instrument for this particular experiment. The last experiment that I'm going to talk about on the mechanical systems side is what's called the journal bearing apparatus. Basically, fitted on the end of an electric motor is a piece of shaft called the journal. It's set screwed onto the actual output of the electric motor. Encapsulating the journal is a bearing housing filled with this green oil. What you're going to try to show in this experiment is the effect of axial and radial pressure distributions on how it's affected by the rotative speed of the actual journal. Journal bearings are found deep inside your internal combustion engines in order to be able to support the crankshaft in your car. Now, the true output of these radial and axial pressure taps was this green manometer, this manometer board full of green oil, where you'd read the pressures in terms of millimeters of oil. What we did to the system is added 14 pressure sensors in order to be able to get electronic output and still not interrupt the actual function of the manometer. And then that gives us the output that you see on the LabVIEW front panel, and then that gives us another way to measure pressure without having to read the meniscus levels of all of those particular tubes. Those are the 4 experiments that I do with groups of 3 or 4 students in a 2-week period of time before we rotate into the next experiment. So it usually takes about half the semester to do this, and then we have a project at the end of the semester that I'll let Dr. Margraves mention about what we've been doing lately.
All right, I'm Dr. Charles Margraves. I'll continue with an explanation of the ENME 4470 Mechanical Engineering Experimentation Lab. As Dr. McDonald said previously, this lab is divided into 2 sections. He covers more of the mechanics options. I'll cover more of the thermal fluids options. Starting with some signage, as he showed you, we're in 2 rooms, 123 and 124. They're internally connected, so we can go back and forth in between. Also, our emergency and medical procedures are posted clearly on the outside. And our open lab policy is described here as well for both of these labs. So with that, we'll head inside. So first thing to show as we enter the room, we have a first aid kit on the door, clearly stated, very close to the fire extinguisher as well. We also have an exit sign listed above the door. And finally, we have safety data sheets on the far wall. We don't do much with chemicals in here, but we do have a few that we have listed there to show. So this lab, as I said, is set up. 4 experiments are done on the ME side with mechanics in mind, and then 4 experiments are done on the thermal fluid side. And the intent of this course is to bring back several courses students have already had, namely Thermo 1, Thermo 2, fluid mechanics, and heat transfer. So we have 4 different experiments to help demonstrate some of the concepts learned in those classes. First one's very simple. It's a transient heat transfer conduction experiment. We have 2 metal spheres, 1 aluminum and 1 stainless steel. Those spheres are put in different environments, and then the temperature response over time is measured to see if lump capacitance is a good assumption or not. So students really learn how to use thermocouples, take data, analyze the data with regards to heat transfer experiment. The second experiment I'll show you in here is a steam turbine power plant, also known as a Rankine cycler. In this particular experiment, we use propane as the heating source to boil the water. So we have a contained boiler here. We have a turbine that allows, once we get to steady state, the steam to enter, generate power that can be measured, and then we have a condenser on the back end. So for safety, while propane burns relatively clean, we have 2 monitors set up to the side here. One measures CO2 and one measures CO. Never had a problem, but we have those just in case. And then finally, hard to see, but on the ceiling back there, we have an exhaust fan that pulls this up and out of the room. A couple of things you'll notice on the back, we do have an engine dyno and we have an Onan engine. Those are previous experiments that are no longer run. However, we do have exhaust for that if we chose to do that in the future, but at this point, we're no longer using that. Because of space issues, we're very fortunate to have this on casters where we can move it around to different areas. So I just set these 2 up so you can see them. But once we're finished with this always stays in either this room or the adjacent room because of the propane tank. Also, any extra propane is stored outside and chained up, so we have no tanks actually in here that are not connected to the experiment. This will be the last part of ENME 4470 Mechanical Engineering Experimentation Lab. So for the last 6 weeks, what we've implemented is the opportunity for students to use Arduino sensors. So what you'll see here is an Arduino board, an Uno. We provide the students with a sensor kit that has 35 sensors in it. The first week they just get to play and learn some different sensors and how they work. From that point forward, they begin their final project, which is an air quality sensor. At that point, we teach the students to use a pressure measurement device, a humidity gauge, and also a thermistor. They then take all of the data, collect that into a single file, and once they've prepared the coding correctly, they take that home, run an experiment at home so that they can relate back to the air conditioning experiment that we did previously. So basically they get a load for an air conditioning unit that they can use previous work to update. This gives students a chance to build a sensor from scratch, work on the coding, get the data, and do the final calculations, and we hope that gives them an overall experience on what we do in this lab. All right, last part of ENME 4470 Mechanical Engineering Experimentation Lab is room 108. You'll notice the signage here. You'll also notice the emergency medical procedures listed here, but what you will not see is an open lab policy. This particular room is open to students only when a faculty member is there, so we don't allow students to enter this room unless we're in actual experimentation mode. So as we enter the room, again, you'll see a first aid kit is close to the door, and we also have a fire extinguisher mounted on the other end. The only work that we really do in this lab is for our wind turbine experiment, which I'll show you now. So a few years ago, we decided to start to incorporate some alternative energy production experiments into the lab, and this is the first one that we've done. You'll see on the back end, louvers to prevent any hands from going in, and then on the front end, we also have a mesh cage that will prevent any large debris from flying out, and students are allowed to observe from the side. For a safety procedure, once the wind turbine's turned on, students are required to stay back. So they can still see the experiment through here, but they're not allowed to move into the front until power has been removed from the system. Last thing I want to show you for this particular lab, this is our refrigeration trainer. Again, it's on casters, so as the semester goes on, we push that back into the other energy lab in room 123. That's where we actually conduct the experiment, so this is mainly used for storage at this point. But you'll see the refrigeration trainer here, and then we also have a large duct that we can place on the condenser to look at turbulent flow that fully develops inside of a duct. So that concludes ENME 4470. Thank you.
Hi, I'm Don Warrington. This is the Fluid Mechanics Laboratory, and that's the course and the laboratory at the same time. So this is our signage for the basic safety protocols in this lab, and we require all the students to go through a safety course every academic year. We also have emergency and medical procedures, which we can invoke if we need to, and over here is our open lab policy. I normally do not have the students in the lab when I'm not here. And so that's usually not a major issue for this lab. Come on in, I'll show you what we've done. Right behind the door here is our first aid kit. These tables are where we run 3 of our experiments, the viscosity experiment, and for that I've eliminated all of the toxic materials. All of them are either edible or completely non-toxic, so students don't have to worry about that. Buoyancy and stability has water. In the fluid mechanics lab, water is a big deal. The biggest danger in this lab is getting wet. The last one is a rotating drum experiment, but it's being replaced. We're in the process of transitioning from that experiment to this one, which is our propeller experiment, our newest experiment, which we will debut in the fall. And this is a completely computer-controlled instrumented experiment. We are, however, using pieces from the old experiment in the new one. So we're using our resources wisely in that.
Over here in the corner is our standard ABC type fire extinguisher, which is used for, principally for this lab. The two experiments I have here are the wind tunnel, which is the low speed, low pressure wind tunnel, open wind tunnel. So, and it's, all the moving parts are completely enclosed in it. And behind it, likewise, is the hydraulic jump experiment, the flume, which is also, as you see, completely enclosed. So there are very few dangers in that as well. This is an interesting experiment, especially for our civil engineering students. This lab teaches 3 different majors: chemical, civil, and mechanical engineering students. So let's go into the other part of the lab. This is a very large, spacious facility where we will show you the other 2 experiments. One of them are the pressure gauges. We've expanded these. We've added a couple of testers, but we have 3 testers: our high, and then our medium, and then our low pressure gauge tester. And this is important to teach not only just data collection and data error, but we'll also teach basic hydrostatics. Over here is our flow bench. This is a large flow bench. As you'll see, it goes on about maybe 20 feet long, the table. The pump is down at the other end. It comes up on the back side of the table, and there are 3 traditional pressure gauges. There's a flow meter, digital flow meter. There's a orifice, a flow nozzle, and the venturi on that side. On the other side, we have a rotometer, which we compare with the reference flow. Plus, we do losses across that for equivalent length calculations. We also have this copper pipe where we do our Moody chart experiment, where we actually compare the results from running water through this pipe with the Moody chart. And last but not least, down here is the second orifice. We've retained all of the pressure, all of the manometers are digital except for this one. This one we want the students to see actually what a real live manometer looked like, so that they will understand why we use inches of water and that kind of thing. What the whole concept of hydraulic head is illustrated with this manometer. And last but not least, in the safety, you'll see here, these are the rotating drum experiments, which we're converting to our propeller experiment. And last but not least, this is the very large fire extinguisher here, which is not only for this lab, but also for some of the adjacent labs. So that pretty much covers this lab, and thank you very much for watching.
Hi, my name is Trevor Elliott. I am an assistant professor in mechanical engineering here at UTC, and I will be introducing you to room 114. As you can see above our signage for the room itself, we have signs for open lab policy, emergency and medical procedures, a whole host of posters associated with past projects, and the descriptions of the different scenarios, emergency-wise, you could have within the actual lab. Also worth noting, safety glass in the windows themselves, shattered protection, as well as some protection on the backside for welding and plasma cutting. We also have our first aid kits, as well as our MSDS kits, and we have multiple first aid kits in this particular lab, as well as a standard fire extinguisher for the particular uses in this room. This room is in particular to support our capstone design courses, as well as our SAE Baja team. As noted here, you can see one of our year before last competition vehicles. We also have a whole host of storage aspects for components for the vehicle, fasteners, and various sundry items, as well as one of our toolboxes. A few other toolboxes are out of the space right now. And we have a water break dyno apparatus, a tubing bender, ratcheting tubing bender, as well as a rigid device for cutting and threading tubing. We have obviously our grinders and things of that nature, as well as a combination mini mill lathe. Back in the far back, you might be able to see a plasma table. So we have a CNC plasma table in this room. It is a 2x4, custom built specifically for our specifications. We also have a tubing notcher, as well as a vertical sander and a drill press and sandblasting unit. On this side here, you'll see our 54-inch by 36-inch vacuum forming table. So we do thermoformable plastics as well as thermoformable carbon fiber panels for our SAE Baja vehicles. Here we have our jig table for building the vehicles themselves, as well as our welding station, welding safety supplies, and our mobile ventilation system for welding. We also have, before going into our office space, a CNC mill that has not been set up yet. It was just purchased recently, and we'll have access for those students this coming semester. Inside, we have an office space for the groups to work in. We also have a Wazer desktop water jet, as well as a MakerBot desktop FDM printer for some prototyping aspects. Within the room, we also have 4 computers, all at workstation quality configurations with maxed out RAM for SolidWorks simulations and analysis, and then a general workspace for the students.
Hi, I'm Cecilia Weigel. I'm professor of engineering in the mechanical engineering department, and I teach a course that's called Introduction to Engineering Design. And this lab here, EMCS 107, the freshman design lab, supports that course, as well as other design needs. So here we have our sign broadly shown about our safety procedures in the lab. We talk about our lab, general lab rules. We have hearing protection, which I'll show you where that is. And we have eye protection, and we talk about being careful in using the equipment, and especially making sure you're wearing the correct shoes and wearing dust masks when necessary as well. Over here we have emergency medical procedures that are on this wall, what the students are required to do in the case that occurs. We have some general lab rules that are specific for the course, which is, the number is 1850. And in this course, they're always working with a partner, always wearing eye protection. And then we talk about being some other type of rules that are associated being respectful to others. This lab is an open lab, so they can be down here working on their own. It's open on the evenings and the weekends. When I say alone, they should be, one of the policies is that they should be working with a partner. We do have a lab manager that is in here for different hours during the week, and on call on the weekend if they need help from the lab manager. So, but yeah, there's a minimum of 2 persons in the lab at all times, but it is open and they have swipe card access. So we provide them access after they have shown that they have gone through the training for working in the lab and passed the exams, which are online. As we enter the space, it's a pretty big space. This is nice, and it's pretty much dedicated to the freshman course, 1850. We do have our first aid box here. I don't want to miss showing that, and our fire extinguisher. And we have a safety data sheets and data plan that is included in the space. But mostly what you see is a lot of tables laid out. In this course, we work on projects. And a lot of our projects support people with disabilities. And the goal of these projects is for the students to work through the design process, to develop a solution for an individual with a disability to help them be more independent. So they do a lot of cutting of wood, putting together, using, putting the wood together, nails, glue, etc. They also might work with plastics, etc. But they do a lot of their building in this shop, and they might use our larger shop. So as we walk around, you can see some of the equipment that we have. There is a laser cutter here that is used. We have some smaller tools for the shops for cutting small items and sanding and etc. We have a lot of toolboxes that have materials in them, sawhorses that are needed, a lot of drill presses. And we have our supply of spare wood. When the students don't use it, we have extra that they can use. More various tool cabinets, and they are labeled as to what is in them. So we have different, we have Dremel tools, we have a lot of hand tools, a lot of sockets that are available for them to use. Again, a lot of table space, teamwork space. We have a sewing machine that we're just setting up, so that will be something new for next year that we have here, that we just got. We have over here the hand tools that the students can use. So they are in here, various hand tools, and extension cords as needed. And we have also extra, since this is a creative, the students are trying to be creative. We do a lot of prototyping. So again, the extra wood, etc. could be for prototyping. We also have other extra material that the students might find in here. When we get done with projects and we have some usable material, we keep them, and they may go through here to find items that they can use to prototype, and also bins so that they can store their own materials. And over here, we have lots of storage for nuts, bolts, latches, screws are in here, and we have drawers full of them as well. And and we have over here is our safety glasses and ear protection, so the students can use them. We do recommend highly that the students buy their own ear protection and buy their own safety glasses. So many students do that, and then they have them for whatever lab they go into.
I'm Ben Swords. This is our engineering design lab. If you look here, we have our standard safety sign. It goes over general lab safety rules. Also has our shop equipment listed in here as to what students are allowed to do and what they aren't. We'll get into more detail about that though in a minute. We have hearing protection required, there are pinch points present, and general protective equipment you'll need in the lab. The emergency contact info, my name is listed first, my supervisor or lab director Carl Fletcher is second, and then the dean's office is third, safety and risk management is fourth. As you can see, there's plenty of stuff on this when you need hearing protection, foot protection, safety glasses, and then there's some hazards as well. There's inhalation hazard, there are some poisons are present in here, and then there's some flammable materials. These are our emergency and medical procedures. These are posted outside of every lab as well. Goes into what happens with extreme hazard stuff if they have a spill or anything. Where to find the SDS files, which are right inside the door here. That's typically a standard for this building. It also has our emergency contact info here for chemical emergencies, which is Dr. Bradley Harris. Okay, now we're inside of our engineering design lab. This space is mainly used by our employees here We do allow some students to come in and work on occasion, but only the ones that have been through a rigorous training regime with us. That is set up by me. I dictate who can do what in here. Basically what we do is we allow the student to come in and observe me working on our manual equipment, which is directly behind me here. Have some senior level students that enjoy running the manual lathe here, so I'll let them if they want to, but after I teach them how to do it. We go through a safety shut-off scenario where you cut the machine off if it's an emergency situation. General practice, tie loose clothing back, keep long hair pulled back, no jewelry. Certain clothing has to be worn in here around this equipment. This is a real industrial lab, so it is important that they maintain a safe work environment. After they've went through some rigorous training with me, they're typically about 5 to 10 hours of hands-on work, and then I'll kind of let them do their own thing, but they're not allowed in here unless I'm directly in this shop. This is one of the few labs in the building that is key controlled. It is not swipe access. That's because it presents a high hazard for students if they're in here by themselves unsupervised. We like to keep it that way. That way we know what's going on, and also if a student's been in here working and leaves something in a condition that's not safe, I'll know it immediately instead of finding it the next day or something. We also have behind me a manual milling machine. Both of these are pieces of equipment that I'll allow students to run occasionally. Again, they're typically upper level students. We seldom get a freshman in here that I'll even let near that stuff. Beside that, this red piece of equipment here is a CNC plasma cutter. That does any sheet metal parts we want to make, tabs for our mini Baja car, general things like that. It's a very handy piece of equipment to have. Directly behind me, there's a CNC milling machine. It's actually powered up and I was running it about 15 minutes ago. This is the workhorse of this shop. If I'm running anything, typically this machine's on. This allows us to make complex parts for student projects. I typically do a lot of our capstone design projects or our 3850, 4850 groups. A lot of their stuff comes through here. How that works is they'll submit me a SolidWorks drawing. I'll go over it with them. If I see any issues with it, I'll go through and actually make the design corrections with the students through email. Now that we're coming out of the pandemic, I can start having a few face-to-face interactions with, but that has been difficult. We've had to rely on email solely. I'm a person that prefers to meet face-to-face with them and go through their designs because I don't want to make the same mistakes in the industry that they do here. Behind there is a CNC lathe. It's essentially the same piece of equipment as our manual lathe. It's just a computer numeric controlled version of it. Have a lot of capability there. We can make very intricate parts on it, make a lot of shafts and things like that there. Towards the back of our shop, we have a full host of woodworking products. We have a miter saw, a table saw, and then we have a 4 foot by 8 foot CNC router. The CNC router I use primarily on our first year students' projects. That allows them to make wild designs for like a sensory board or a wheelchair table or something like that. A lot of them do assistive technology stuff, so it's important to give them a good product that's appealing to the eye as well as functional for the student and the person using it. Again, that's one of those that we take a SolidWorks drawing in from our CAD design. They can also use other CAD programs. I can handle most any solid drawing, and we'll convert it into a file type that I can use, and then I'll actually program it, send the program to the machine, and it'll cut it for me. As far as safety stuff in the shop, we have safety glasses available to students. We have hearing protection available. There is some respiration available. We typically don't do a lot of things with chemicals that we need respirators, but occasionally we have to cut something like carbon fiber that requires it. That stuff's available upon request to me. I keep it locked away in a cabinet here so it's all in good, clean working order. There's a first aid kit directly behind you on the door here, as well as the safety data sheet. This is filled out. We go through it every year to make sure that it's current and up to date. And then the first aid kit is here, and it is full and stocked. We check this one quarterly to make sure it's still got everything in it. Since this is a low access area, I don't have a problem with a lot of our stuff getting taken out, but we do have to replenish it some. And again, this is a keyed area, so students don't just wander in. I keep the door locked at all times. They knock in. Typically we set up a meeting time and do it that way, but if they just wander in, we can always accommodate them. We have fire extinguishers in the back. There is one directly against the back wall. There's another in the very back corner of the shop. Those are serviced by our facilities safety and risk management group. They come through, I think, quarterly to do those. Fill the tags out and make sure everything's good with them.